Welcome to Podkey Slopcast, where AI hype meets patch queues, pricing wars, and moral guardrails. A model finds 10,000 serious bugs, a government quietly buys billions in chips to run systems like it, and the people who have to fix the mess are still very much human. That gap between machine speed and institutional capacity shows up in almost every story here. The clearest hard fact in the Anthropic story is scale. Mythos reportedly surfaced more than 10,000 high-severity software vulnerabilities in its first month, and some partners said they each saw hundreds of critical bugs. If those numbers hold up, this is more than a better scanner. It changes the limiting factor. The question stops being, can you find exploitable weaknesses, and becomes, can you responsibly validate them, prioritize them, patch them, test the patch, and ship it without breaking everything else? The reported false positive rate matters here. Under 10% on open-source repositories is impressive, because security tooling often dies in practice when it floods teams with junk. Mozilla and Palo Alto networks also reportedly saw around 10 times and 5 times more patched bugs than with previous tools, which suggests at least some of the output was actionable, not just noisy. Still, there are a few important caveats. Open-source test results do not automatically translate to messy enterprise codebases, and patched bugs is a stronger signal than bugs found, but it still doesn't tell us whether the model is best at finding easy wins, whether severity scoring is consistent, or whether teams shifted resources from other useful work to chase model-generated findings. One of the most revealing details is that some partners asked Anthropic to slow public disclosure because the volume outstripped their ability to triage and remediate. That is not the story you tell if the bottleneck is model quality. That is the story you tell when the machine side is moving faster than the organization around it. Then there is the national security angle. The White House reportedly approved a secret $9 billion budget for the CIA and NSA to buy NVIDIA Blackwell chips for Mythos-class models in classified environments. The important point is not just that government wants AI, it's what kind of AI workload gets priority. Vulnerability discovery, code analysis, and cyber operations all fit a world where compute is strategic infrastructure. The contradiction inside government is also worth pausing on. The Pentagon labels Anthropic a supply chain risk, while the NSA still moves ahead with a contract to use Anthropic models. That doesn't necessarily mean one side is wrong. It may mean agencies are optimizing for different threat models. One is asking whether the vendor is safe enough for procurement. Another is asking whether the operational value is too high to ignore. That divergence tells you something broader. Government approval is not one coherent standard. It is a patchwork of mission needs, internal controls, and bureaucratic risk tolerance. So when people frame adoption as proof of trustworthiness, that is oversold. Sometimes it is proof of urgency. This is the quiet center of the whole episode. AI can increase discovery rates dramatically, but discovery is only the front end of security work. The expensive part is the human chain that follows. Security engineers have to confirm the issue, understand exploitability, decide whether it matters in their environment, design a fix, test dependencies, coordinate deployment windows, and sometimes persuade product teams to accept near-term pain for long-term safety. None of that disappears because a model got better. That is why the comparison to a kind of Jevons paradox is useful, even if the label got mangled in the source. When the cost of finding bugs collapses, demand for downstream security labor can rise rather than fall. You do not save labor if the cheaper input causes total work volume to explode. The likely near-term consequence is not fully automated remediation. It is hiring pressure, more triage analysts, more application security engineers, more people who can translate a model's finding into a patch that survives production. There is also a second-order effect. If elite firms can absorb the flood and weaker firms cannot, AI vulnerability discovery could widen the security gap between organizations with mature engineering processes and those without them. The model may be available to many players, but the capacity to act on its output is not evenly distributed. DeepSeek's V4 pricing is aggressive enough that it deserves to be treated as strategy, not marketing garnish. 44 cents per million input tokens and 87 cents per million output tokens, with a permanent 75% discount, puts it at roughly 1/7 the cost of Anthropic Opus 4.6 and about 1/4 the cost of OpenAI's GPT 5.4. For startups and other token-sensitive buyers, that changes the adoption calculus immediately. A lot of AI use cases do not fail because the model is bad. They fail because the usage bill makes the product economics ugly. If DeepSeek is good enough for a task at a fraction of the price, good enough becomes a powerful competitive weapon. The phrase to underline there is good enough. Low price alone does not settle the market if reliability, compliance, latency, support, or political risk differ in meaningful ways. Enterprises buying for sensitive workflows are not choosing on token cost alone, but plenty of developers are, especially at the experimentation stage. The funding round reinforces that this is not a coupon campaign, a $10 billion series round at a $45 billion valuation, with participation from China's state AI fund plus Tencent and JD.com, signals strategic backing as much as financial confidence. That matters because cheap pricing is easier to sustain when investors and the state are aligned around market share, ecosystem influence, and national capability. In other words, the low price may be part of a broader push to shape the global open source and developer landscape, not just to win a quarter. The missing context is whether these prices are sustainably profitable, temporarily subsidized, or designed to pressure rivals into margin compression. We do not have enough here to know, but we do have enough to say this is a serious competitive move, not a vanity headline. xAI's Grok V9 Medium reportedly finished training and moved into fine-tuning at 1.5 trillion parameters, up from the 0.5 trillion parameter V8 Small that had been used in production coding tasks. That is a notable jump in model scale. But parameter count is the easiest number to overread. Bigger can help sometimes a lot, but performance depends on data quality, architecture choices, training efficiency, fine-tuning, tool use, and inference stack. So the sound conclusion is not V9 will dominate, it's that xAI is making a serious attempt to move up a performance tier. The early coding chatter is interesting, but still soft evidence. Reports that Grok build feels faster and returns fewer bugs than Claude in some coding contexts point to real user-perceived gains, yet those are not controlled benchmarks. They tell us there may be momentum, not that the race is settled. The $300 a month Super Grok tier also says something about positioning. xAI appears to be targeting heavy users who care about top-end capability and priority access, which is a different bet from competing mainly on commodity pricing. One company is pulling the market down on cost, another is trying to capture premium demand. Pope Leo XIV's first encyclical, Magnifica Humanitas, is easy to caricature if you only hear the headline. The substance is more specific than generic fear of technology. It treats AI as a civilizational turning point on the scale of the Industrial Revolution and tries to apply an older moral framework to a new technical order. The strongest and clearest claim in the document is the rejection of AI personhood. It says these systems do not feel joy, pain, love, or moral conscience. They simulate empathy through statistical adaptation, but they do not enter relationships or spiritual growth. Whatever one thinks theologically, that is at least conceptually crisp. It refuses to confuse convincing outputs with lived interior experience. The warning about data colonialism is also more concrete than it sounds. The point is that control over health and research data can create structural leverage over markets, medicines, and investment decisions for entire populations. That concern does not require mystical language. It is basically a power analysis about who owns the inputs that shape future systems. On labor, the encyclical pushes back against the idea that efficiency and profit automatically justify deployment. Public policy, in this view, should measure success by human dignity and social participation, not just output per worker. You do not need to be Catholic to see the policy relevance. A lot of current AI debate quietly assumes displacement is acceptable if aggregate productivity rises. The interesting tension is that the Pope is framed as tech-savvy and forward-looking, not anti-tech. So the document is not saying stop innovation, it is saying do not let the metric of optimization become the metric of the human person. Whether that changes policy is another question, but as a moral intervention, it is much sharper than the usual hand-wringing. Across all of this, the recurring pattern is simple. Model capability is scaling faster than the institutions around it can absorb. That doesn't make the gains fake, and it doesn't make the risks apocalyptic. It means the real contest is now between technical acceleration and human governance. Thanks for listening to Podkey Slopcast. This episode was generated by Podkey. Create your own at podkey.fm.